we are talking about experimental probability, and I'm going to explain to you the difference between experimental and theoretical probability. So theoretical probability is what we've been talking about. There's a 50-50 chance that when you flip a coin, you get heads or tails. But I don't know if you guys have ever done this, but like when you flip a coin just over and over and over again, it's not going to go heads, tails, heads, tails, heads, tails, even though it's a 50-50 chance. You could get heads, 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 then tails or something like that. So the experiment is actually going through and it's flipping that coin. Then experimental probability is using the experiment to predict what's going to happen in the future. Experimental probability is usually from a table. And theoretical probability is just from the word problem itself. Okay. So the probability of an event is what we want to happen. Over the total number of times. So in an experiment, it's the total number of times that the experiment is performed. And theoretical, it's just over the total. Okay. So the first one says, Jana has a bag of 20 colored tiles. 9 are green. So since I see this 9 right here, I'm going to go through and I'm going to put a 9. 6 are red. Same thing here. I'm going to put a 6. 3 are blue, so I'm going to put a 3. And 2 are yellow, so I'm going to put a 2 there. Jana draws a tile from the bag and replaces it 50 times. So this right here is very important. This is her total. The results of the experiment are shown in the table. So from this table, we can read that she got green 22 times, red 15 times, blue 5 times, and yellow 8 times. And so it says, based on these results, find the experimental probability of each color. So for green, I see that green occurred in the table 22 times. So 22 is going to go on top. And then on the bottom, it's going to be the total number of times that we performed it. So we performed it 50 times. I'm not actually going to have us turn this into a percent. To turn it into a percent, we would just divide it and then multiply it by 100. But I'm not going to do that here. Instead, we're just going to simplify. So 22 and 50 are both divisible by 2 because they're both even numbers. So 22 divided by 2 is 11, and then 50 divided by 2 is 25. So there's my experimental probability for that. For the red, I would first go to the red part of this right here, and I would see, oh, red's been done 15 times. So I would do 15 over how many total times the experiment has been performed. So that would be 15 over 50. So 15 ends in a 5 and 50 ends in a 0, which means that both these are divisible by 5. 15 divided by 5 is 3, and 50 divided by 5 is 10. So we have 3 over 10. For the blue, I would go up into my table, and I would get the blue out. So there's the blue. It occurred 5 times. We're going to put that over the number of times that we performed this experiment, which was 50 times. So both 5 and 50 end in either a 5 or a 0, which means they're both divisible by 5. 5 divided by 5 is 1, and 50 divided by 5 is 10. Okay, I want you to try to find the experimental probability of the yellow. For the yellow, we know that the experiment, after we pulled the tiles out 50 times, we got yellow 8 times. So 8 goes on top, and we perform the experiment a total of 50 times. 8 is even and 50 is even, which means these are both divisible by 2. 8 divided by 2 is 4, and 50 divided by 2 is 25. Now, that's experimental probability. We pulled that information from the table. Theoretical probability, we're going to pull from the word problem itself. So that would be the 9 are green, 6 are red, 3 are blue, and 2 of the tiles are yellow. And our total for this one is the total number of tiles. So it's not that we perform the experiment 50 times, it's just what we think is going to happen. So this is what we've been doing. We haven't been performing an experiment. We've just been saying, okay, I'm going to look at this and I'm going to think of what would happen. So when we look at the green, it says that 9 of the tiles are green. So I'm looking at the tiles themselves. 9 are green. And then I do have a total of not 50 tiles. That's how many times the experiment was performed. So I don't care because we're not dealing with experimental probability right now. We have a total of 20 tiles. So 9 out of 20 of the tiles are green, which means there's a 9 out of 20 chance that we'll pull a green. For the red tiles, 6 of the tiles are red, and there are 20 total tiles. So I would have 6 over 20. 6 and 20 are both even numbers, so I would divide those both by 2. 6 divided by 2 is 3, and 20 divided by 2 is 10. Okay, the next one is blue. So my theoretical probability is the number of blue tiles that I have over the total number of tiles there are altogether. So I have 3 blue tiles, and that is in a bag of 20 tiles. So that would be my total. I want you to try to find the yellow theoretical probability. Remember, it's the number of tiles over the number of total tiles. So we see up here in our word problem that there are 2 yellow tiles. So that's my numerator. And then my denominator is the total number of tiles that there are. There are 20 total tiles. So now I look at 2 and 20 and I see that they're both even, which means they're both divisible by 2. 2 divided by 2 gives me 1, and 20 divided by 2 gives me 10. Okay, now we're going to come down here. A number cube was rolled 100 times. So this is actually performing the experiment. So we actually did this. The results are shown in the table. Based on these results, answer the questions below. So it says, what is the experimental probability that the next time the number cube is rolled, it will land on an odd number? So we have to look at our odd numbers. I have this odd number here, this odd number here, and this odd number here. Now, on a dice, yes, the number 1 only occurs 1 time. But when we actually went through and we rolled it, we got 1 5 times. We got 3 12 times. We got 5 14 times. So the way that I figure out the probability is I go through and I say, okay, so I got 1 5 times, plus 3 12 times, plus 5 14 times. So experimentally, that's how many odd numbers I got. And the denominator is going to be the total number of times that you perform that experiment. So the total number of times we performed that experiment was 100. Then we're just going to combine all of it together. So 5 plus 12 is 17, and 17 plus 14 is 31. So there's a 31 out of 100 probability that the next time we will get an odd number. Okay, the next one says, what is the experimental probability that the next time the number cube is rolled, it will land on a number that is less than 3? So I know that 2 is less than 3, and I know that 1 is less than 3. So 1 was rolled 5 times, 2 was rolled 16 times. So I would say 5 plus 16, and then I would put that over the total number of times the experiment was performed, which was 100. 5 plus 16 gives me 21 over 100. This one says a spinner is spun and a coin is flipped 20 times. So right here, we see 2 actions were performed. Remember, this is what we learned yesterday. When 2 actions are performed, you have to multiply your probabilities. So a spinner is spun and a coin is flipped 20 times. The results of, you know what? Forget that. Still right with the 2 actions, but the way that they present it in the table is not based off of that. So we're not going to put an X through this right here. Not through the whole problem, just put an X. Okay, so the total number of times the experiment is performed is 20. And then it wants to know, what is the experimental probability of the spinner landing on a 1 and the coin landing on heads? So when we look at our table, we see that the spinner lands on 1 here and heads here. That happened 1 time. So my experimental probability is that that would happen 1 time over 20. And then the same thing here, X this out. This one says, what is the experimental probability of the spinner landing on an even number and the coin landing on tails? So if we look, 1 is not an even number, so we're not going to go with these. It wants the coin to land on tails, so we can't have one where it lands on heads. Here is an even number right here where it lands on tails. Then 3 is odd, 3 is odd. 4 heads, we want tails, and then we have 4 tails right here. So my experimental probability, I want you to try to find that now using that the 2 with tails was rolled 2 times and the 4 with tails was rolled 3 times. So what you should have done is you should have said, okay, so I've got 2 times that an even number was rolled with tails, and then 5 times that an even. That's not correct. That's a 3. I'm so sorry. So you got 2 and you've got 3. And then the total number of times that the experiment was performed was 20. So we would get 5 over 20. 5 and 20 are both ending in either a 5 or a 0, which means they're both divisible by 5. 5 divided by 5 gives me 1, and 20 divided by 5 gives me 4. So that's a 1 in 4 chance. Okay, there's a lesson from today. If you need additional assistance, go ahead and go watch the Edpuzzle to complete your assignment. So sorry that this is the way that I have to do class today.